Hello learners, welcome to this program Education Online. I am teacher Akena Patrick Omoy, a teacher of physics. So today we are going to look at image formation by concave or diverging lens. Now before we look at image formation by a concave or diverging lens, we have to know what a concave lens is. So we say a concave lens is a type of lens that is thicker at the edges than in the middle. As we said, there are two types of lenses. One is called the concave lens and one is called the convex lens. So a concave lens is a type of lens which is thicker at the edges than in the middle. So this is how a concave lens appears. It is thicker at the edges than in the middle. So when you look at this lens, when you look at the two edges, that is from the upper edge and the lower edge, they are thicker. Then when you look at it from the middle, it looks thin. So it is thicker at the edges than at the middle or in the middle. So now image formation in a concave lens shall be got by drawing ray diagrams. And we say a ray diagram is an illustration of how we can locate the position and the nature of image formed by a concave lens. Now for us to draw these ray diagrams, we have certain rays that we have to consider. We have three rays that will always pass through the concave lens, but in the drawing of the ray diagram we shall consider two of the rays. Now the first ray that we are going to use is a ray parallel to the principal axis, which appears to diverge from a point called the principal focus. After refraction from the lens. So this is the first ray that we are going to consider. A ray parallel to the principal axis which appears to diverge from a point called the principal focus of the lens, that is after refraction. So this is the ray that we are going to consider. If this is our concave lens, this is the concave lens, then a line through the center of the lens is called the principal axis. So this is the principal axis of the lens. So this is principal axis. So now a ray that will be parallel to this principal axis will appear to diverge from a certain point which is called the principal focus of the lens, that is after refraction from the lens. Now there are points on the principal axis, and this point we call it the principal focus, and the principal focus is on both sides of the lens. So this is also the principal focus. Then twice of the principal focus forms the or is equal to the radius of curvature of the lens, but we denote it with 2f, meaning it is twice the focal length, 2f. So now what we are going to do, we shall consider a ray a ray which is parallel to the principal axis. So this ray is parallel to the principal axis. With ray diagrams, we indicate it with an arrow which shows the direction of propagation of rays. So when this ray touches the lens, this ray is going to diverge. And when it diverges, it will appear to be coming from a certain point which is called the principal focus found on the principal axis. So this ray will be diverted in this direction. So once it touches the lens, it is going to be refracted. So when it is refracted, it will appear to be coming from a certain point which is called the principal focus of the lens. So it will appear to be coming from the principal focus of the lens. So this is one of the rays that we shall use when we are drawing the ray diagram, and we are when we want to indicate the characteristics and the position of the image formed by the concave lens. A ray parallel to the principal axis which appears to diverge from a certain point called the principal focus after refraction from the lens. Then the second ray that we are going to use is a ray through the optical center, which goes undeviated. So this is the second ray that we shall use when we want to indicate the position and the characteristics of image formed by a concave lens. So now, how does this ray appear? A ray which is through the optical center. We said optical center is a point between the poles of the lens. If this is our concave lens, then we say a line through the optical center is called the principal axis of the lens. So this is the principal axis. This is the principal axis of the lens. Principal axis. Now there are points on the principal axis, and those points we call them the principal focus. And the principal focus is on both sides of the lens. So these are the two principal foci. Then twice of the principal focus is called the radius of curvature, but we denote it with 2f. Since radius of curvature is twice the focal length, we denote it with 2f, and it is also on both sides. 2f on both sides of the lens. So now the ray that we are using is a ray through the optical center which goes undeviated, meaning the ray will not be refracted as it passes through the optical center. So, and this point is what we call the optical center. So if this is a ray of light, so this ray of light, when it passes through the optical center, it will not be refracted, or we can say it goes undeviated, means its direction will not change. And a ray is always represented with an arrow. The arrow shows the direction of propagation of the ray. So this is the second ray that we shall use when we want to indicate the position and the characteristics of image formed by a concave lens. Then the third ray that we shall use, because there are 3 rays that we have, but out of the 3 we shall use 2 of them. And the first one we say a ray parallel to the principal axis which appears to diverge from a point called the principal focus after refraction from the lens. Then the second ray is a ray through the optical center which goes undeviated. So the third ray that we have is a ray appearing to pass through the principal focus, which emerges parallel to the principal axis. Parallel to the principal axis. The principal axis. That is after refraction. After refraction from the lens. Refraction from the lens. Dear learners, let's also look at how this ray will move through the concave lens. That is a ray appearing to pass through the principal focus, which emerges parallel to the principal axis. That is after refraction from the lens. Now, considering the concave lens or the diverging lens, if this is a concave lens, this is our concave lens, then a line passing through the optical center and the principal focus is called the principal axis of the lens. So this is the principal axis of the lens. Principal axis. Principal axis. Then there are points on the principal axis, and those points we call them the principal focus. And the principal focus are on both sides of the lens, and they are at the same distance from the center of the lens or the optical center. And we say twice of the focal length forms the radius of curvature, but we denote it, we say 2f. 2f is twice the focal length, which is the radius of curvature. So now this ray is a ray which appears to be passing through the principal focus, but after it comes into contact with the lens, it is going to emerge parallel to the principal axis. So this ray is appearing to pass through the principal focus. So if this is the ray, and when it comes into contact with the lens, what happens is it will be refracted parallel to the principal axis. It will be refracted parallel to the principal axis. So this is how the ray will be refracted. But this ray, when we try to project it in its original direction, it will appear to be passing through the principal focus of the lens. So it will appear to be passing through this point, which is called the principal focus. So dear learners, these are the three rays that we shall always use when we want to locate the position and state the characteristics of image formed by a concave lens. The first ray is a ray parallel to the principal axis, which appears to diverge from a point called the principal focus. That is after refraction from the lens. Then the second ray is a ray through the optical center, which goes undeviated, meaning when it passes through the optical center, its direction will not change. It will go without refraction. Then the third ray is a ray appearing to pass through the principal focus, which emerges parallel to the principal axis. That is after refraction from the lens. Now, after knowing these three rays, we are now going to use two of the three rays to locate the position of image formed when an object is placed at various positions on or in front of the lens. So one, we are going to look at an object placed at the principal focus. That is an object placed at F. That is the principal focus of the lens, where we said a principal focus of a concave lens is a point along the principal axis where all rays that are parallel and close to the principal axis appear to diverge from after refraction from the lens. So one, let's look at the first position of the object. That is an object at F. An object at F, meaning an object placed at the principal focus of the lens. So now if this is our concave lens, this is the concave lens, then a line through the optical center, and the principal focus is called the principal axis. So this is the principal axis of the lens. The principal axis of the lens. Then on the principal axis we have the principal focus F on both sides of the lens, and twice of the principal focus is the radius of curvature, which is equals to 2F. Now the first ray that we are going to use is a ray parallel to the principal axis, which appears to diverge from a point called the principal focus, that is after refraction from the lens. So this is a ray which is parallel to the principal axis. So this ray is parallel to the principal axis. Once this ray comes into contact with the lens, this ray will be refracted, but when it is refracted, it will appear to be coming from a certain point called the principal focus of the lens. So this ray will be refracted in this direction. So when it touches a ray which is parallel, when it touches the lens, it's going to be refracted in that direction. But it will appear like the ray is coming from a certain point, which is called the principal focus of the lens. So this ray will appear like it's coming from a certain point on the principal focus. So this is the first ray that we shall use. Then the second ray that we are going to use is a ray which passes through the optical center undeviated, meaning when it passes through the optical center, its direction will not change, or it will not be refracted. And this is how the ray will appear. This ray will pass through the optical center, and we shall find that this ray goes undeviated, meaning its direction will not change. So now, dear learners, where these rays are intersecting is where the image of the object is formed. So this is a point where the rays are intersecting. This is a point where the rays are intersecting. This object is placed at the principal focus. So the object, we call it O, then the image, we call it I. So dear learners, it is from here that we are going to state the characteristics of this image which is formed. So now, looking at our ray diagram, we shall find that when you look at the object and the image, we can see the object is bigger than the image. So we are going to say the image is diminished. The image is diminished. Meaning the image is smaller than the object, as we see from the ray diagram. Then the second characteristic that we have is, when you look at these two rays, the first ray just appears to be coming from a certain point called the principal focus. So it is not a true ray, since this image is formed by apparent intersection of rays. We say that image is visual. The image is visual, meaning it is formed by apparent intersection of rays, or we can say it is not formed on the screen. Then when we look at this image is facing upward, so we say the image is upright. The image is upright, or we use the word erect. The image is upright or erect. Then the last characteristic that we have is, when you look at the position of this image, we shall see that the image is formed between the principal focus and the optical center. So we say the image is between F, which is the principal focus, and the optical center. Optical center. So dear learners, this is how we state the characteristics of the image formed by a concave lens, that is for an object placed at f, or at f, which is the principal focus of the lens. So the two rays that we have used are, one, a ray parallel to the principal axis which appears to diverge from a certain point called the principal focus after refraction. Then the second ray that we have used is a ray through the optical center which goes undeviated, meaning its direction does not change or it will not be refracted. Dear learners, let us also look at a second position where we can place an object. Then we see also the characteristics of the image that will be formed. Now the second position is we are going to place an object between f and 2f. We place an object between f and 2f. Say an object between f and 2f. So this is the second position where we can place an object. So now let us also draw a ray diagram. Then we see where the image can be formed when the object is placed between f and 2f. Considering a concave lens still, this is a concave lens. Now if this is our concave lens, then a line through the optical center and the principal focus is called the principal axis of the lens. So this is the principal axis of the lens. Then on the principal axis we have the principal focus on both sides, and they are at equal distances from the optical center. Then twice of the focal length, we denote it as 2f, but 2f is equals to the radius of curvature of the lens, and the 2f is also on both sides. Now dear learners, we are going to place this object between f and 2f. When we look at this drawing, we shall find that the position between 2f and f is at this point. So this is where we place our object. This is where we place our object between f and 2f. And when we write O, we mean the object. So now we are going to consider a ray that will be parallel to the principal axis. Now this is a ray parallel to the principal axis. That is a ray of light from the object. A ray of light from the object parallel to the principal axis. Now when this ray meets the lens, this ray is going to be refracted in a direction where it will appear to be coming from a point called the principal focus. So this is how the ray will be refracted. It will be refracted in that direction. So when this ray is refracted from the lens, this ray appears to be coming from a certain point called the principal focus. So this ray appears to be coming from this point called the principal focus. That is after refraction from the lens. Then dear learners, we are also going to use the second ray. That is a ray through the optical center which goes undeviated, meaning its direction will not change. So this is a ray which goes undeviated, that is through the optical center. So the direction of this ray will not change. So now when we are to look at where these two rays are meeting, they are meeting at this point, that is between the principal focus and the optical center. So it is from here that we are going to state the characteristics of the image that is formed. So now when we look at this ray diagram, when we look at the size of the object and the size of the image, we shall find that the object is bigger than the image. So we are going to say the image is diminished. The image is diminished. Meaning the image is smaller than the object, as we can see from the ray diagram. Then the second characteristic is that we shall see these two rays. The first ray is not a true ray, so it just appears to be coming from this point. So these two rays, or the image, is formed by apparent intersection of rays. If it is formed by apparent intersection of rays, which means the image is visual. The image is visual, meaning it is formed by apparent intersection of rays, or in other words, we can say it is not formed on the screen. Then still, when we are to look at this image, we shall find that the image is facing upward. So when it is facing upward, we will say the image is upright. The image is upright. Or we use the word erect. The image is erect or upward, meaning it is facing upward. Then the next characteristic is that when we look at the position where the image is formed, we shall find that the image is formed between the principal focus and the optical center. So we can say the image is between the principal focus and the optical center So these are the characteristics of the image formed when an object is placed between 2F and F. So dear learners, this is how we can state the characteristics of image formed by concave lens. Now looking at these two ray diagrams, that is when the object is placed at the principal focus and when the object is placed at a point between the principal focus or a point between 2F. We shall see that the characteristics of the image is just the same. When it is at F, the image is diminished, means smaller than the object. The image is visual. The image is upright. The image is between F and the optical center. Also the same thing, when we place the object between F and 2F, we shall find that the characteristic of the image form will just be the same. So now we are going to summarize to say, for any position of the object placed in front of a concave lens, the image will always have the same characteristics. We can say all images formed by a concave lens are, so these are the characteristics of the images formed by concave lens at various positions. 1, the image will always be diminished. Then 2, the image will always be visual. Then 3, the image will always be upright. And lastly, the image will be formed between F and optical center. Therefore, the position of the object will never change the position where the image is formed, and the position of the object will never change the characteristics of the image formed, that is by a concave lens. So dear learners, a question can be given. You can be asked question you can be asked using a ray diagram, state the characteristics, of an image formed by a concave lens. So this is how a question can be given. So dear learners, when a question is given like this, what you need to do is you consider the three rays that we have named. One is a ray parallel to the principal axis which passes through, which appears to be coming from a principal focus after refraction. Then the second ray is a ray through the optical center which goes undeviated. Then the third ray is a ray which appears to pass through the principal focus but emerges parallel to the principal axis. So up to this point, I would like to say thank you for attending the lesson. I am teacher Kena Patrick Omony. Bye bye for now.